All right, so we are starting test 3, notes on energy. All right, the first question we have now is this, then. What is energy? So I'm going to go ahead and write down some stuff while I'm getting this phone call, which seems to always happen in the middle of video. Yes. You're welcome. India to Mr. Harris's office. So, obviously, since we're learning about energy, the first question we want to know is, what is energy? Now, most of the time when you ask people what is energy, you're going to hear the most common answer being is what you need to do stuff. All right, and that makes sense because obviously we've been told our whole time in our whole life that we eat, so we have energy so that we can do what we got to do. Well, energy is the ability to do work. All right, so you're right. It is something that we need in order to do things, and those things that we do are what we refer to as work. But there is another definition for it, which is a more textbook or scientific definition for it, which is the ability to cause change. So for you to, when you're doing work, for example, a simple job as moving, if you're helping a family move out of their home, well, what happens is usually they have furniture that's in place. For you to be able to move that furniture, you need energy because you're going to have to use your muscles to lift things up, to move them, which is to create a change. All right, because again, we said before, if a box is sitting on the floor, the law of inertia says it ain't ever going to move, okay, unless you can apply a force to move it. Well, for you to apply that force to move it, to cause that change, you're going to need energy, all right? And what specifically needs energy are your muscles in your body, but your muscles in your body get that energy from another source of energy, which is the food that you eat. So that's, the general idea that we're trying to understand here is energy is what we need to do things. But what we need to do now is we need to get a little bit of a better understanding in regards to what it is and what it isn't. Now, energy is a unit of measurement. So just like force was measured in what unit? Newtons, right? Distance is measured in what unit? Meters, right? Here's one to make you think, just to make sure. Acceleration is measured in what unit? Meters over second squared. Very good. Well, energy is a measurement, so therefore it's also measured in a unit. The unit of measurement for energy is a joule. Joule. Okay? And the reason why it's a joule is because it's named after a scientist named James Prescott Joule. All right? So it's called a joule after the scientist who did a lot of his studies on energy, just like we call the force a Newton because it's named after who? Isaac Newton, right? Sir Isaac Newton. So it's the same idea. So a joule is the name of a person, all right? And that's where we get the unit of measurement for energy from. It's from the name of a person. Again, his name was James Prescott Joule. Now, kind of like the force that we talked about, a force is measured in newtons, but a newton is actually a kilogram and a meter per second squared combined together. Matter of fact, some of you on your test the other day, when you were answering a question on force, you actually gave me a number, and then you followed that number with kg times m over s squared. All right? And that was fine because a newton is a kilogram times meter over s squared. So some of you got credit, even though you didn't use newton, but you still gave me the correct units for force by giving me the kilograms times meters per second squared. Well, that's the same thing here. A joule is the same thing as a newton meter. Okay? So some of you will do a problem, and you may do what you did yesterday, all right, which is you may give me the number, and some of you might give me 8 joules, but some of you might give me 8 newton meters. Both of them are acceptable. Just like, for example, if Eric said, hey, I need $20, would you accept a $20 bill? Yes. Would you accept a $10 bill, a 5 and 5 ones? Yes, because even though it's a different makeup, it's still the same thing. That's what we're saying here. A joule is the same thing as a newton meter. It's different, but it's same representation, same amount. Okay? Any questions so far on this slide? So we're good? The main idea right now from this slide is this. There's 2 things. Number 1, energy is what we need to do things, and then we measure energy in joules. All right? But now, what we're about to get into here is this aspect. All right? When we talk, hold on, we're going to switch that one. Okay. When we talk about energy, So now here's what we're going to do. Go ahead, go to types of energy now. So the next thing now we're going to get into types of energy. And there are many different types of energy. All right, but what I want to make sure we're focusing on is the two general categories. All right, so today we're focusing on categories of energy, not necessarily types. For example, there are many different types of humans, but there's only two categories of humans, right? Males and females. But now you can have in the male category, you can have Spanish, you can have Asian, you can have Caucasian, you can have African American, you can have, I don't even know what some other ones are, right? But then we could even go more specific, right? Because if you're Asian, right? If you're Asian, you could be from Japan, Japanese, you could be from Thailand, you could be from Vietnam, you could be from China, all right? And I know this in the realm of Hispanics, all right? Well, there's a lot of Spanish countries. You could be Mexican, you could be Argentinian, you could be Spanish, as in from Spain, right? And I know this, here's something I do know. If you're Mexican, don't confuse them as Dominican. If you're Dominican, don't confuse them with Cuban. And those are all Spanish. So even those types. But so what we're focusing on today is this. There are many different types of energy. Like you have chemical energy, like in the food you eat. You have mechanical energy in the things that move. You have gravitational energy in the fact that things that are higher up can cause more damage. All right. You also have thermal energy. Those are all different types. But right now I'm not worried about the types. What I'm worried about are the two categories that all these types can fit into. All right. Those two types that we can fit into are kinetic and potential. All right. So right here, the first question we're throwing here at you, and this may be something you've heard from like when you were in elementary school. What do you call energy related to motion? All right. In elementary school, it may have even been called energy of motion. Do you remember what that energy was called? Kinetic. Okay. Kinetic. So therefore, kinetic energy is energy of motion. So when we're talking about energy, one of the categories that we talk about energy being in is it being used or is it not being used? So another definition I'm going to give you here underneath energy and motion is I'm going to say here, energy being used. All right? Because I like to think of energy like money. Okay? I like to think of energy like money, which is either you're saving money or you're spending money. That's the only two categories that it fits under. Okay? For example, you'd say, no, it ain't, because I'm not saving money that's in my pocket, but I'm not spending it. Well, no, you are saving it. It's just that there is a short-term saving and then there is a long-term saving. Okay? So in the case of money, either you're spending money or you're saving money. Well, that's the same thing with energy. Either energy is being used or it's not being used. When the energy is being used, we call it kinetic energy. You've known it as energy of motion, but there are going to be some things that aren't as obvious where the motion is, but the energy is being used. So if you look at it as, either energy is being used to do work or the energy is not being used to do work, then that's kind of how we look at energy in the categories. Either you're being used or you're not being used. Either you're being spent or you're not spending it. So that's what we're looking at here. Kinetic energy is me spending money. Okay? That is me spending money. So that's the one area right now. But now here's what we get into. So now we're getting ready to take a look at some formula stuff here, because here's where things can get confusing. Kinetic energy depends on two things. So right now, I want you to go to your formula sheet, and I want you to look at this formula. The one I'm writing on the board, you don't have to write yet, because we're not there yet. But I want you to find that formula. Now this formula is going to pose a little bit of a problem for you, especially if you don't remember what you've learned in algebra, which, again, depending on what school you went to, some people learned it as PEMDAS. Some people learned it as, please excuse my dear Aunt Sally. Okay? That was to help you remember the order of operation. Okay? You have to remember the order of operation for this formula up here, because if you don't, you're going to notice that you'll do it your way and get an answer that's different from the way that I do it. All right? And the reason why your answer will be different is because you went out of order when I went in the correct order. So you got to remember PEMDAS, or please excuse my dear Aunt Sally. Okay? Is anybody in here not familiar with either one of those two things that I'm talking about? Because now would be a great time for you to admit it so we can correct it. Otherwise, I'm proceeding forward as if you know it. So everybody's good. All right. So, taking a look at this formula, right? See the formula up here? The only variable up here that you don't know is that one. And now you know it because we already told you what it stood for. What does it stand for? kinetic energy. So that's kinetic energy. So according to the formula, what does kinetic energy depend on? So look at the formula to get your answer. Say what? It depends on velocity. Sorry. It depends on velocity and mass. That's what you get when you combine mass and velocity. You get velocity. All right. So mass. That's one thing. But now what we need you to see is we need you to see how does mass affect kinetic energy. Okay. So here's what I want us to look at. All right. We're going to look at this formula right now. Okay. And for right now, so get your calculators ready, because here's also now where I'm going to show you that little thing of that's going to be an issue for us. So right now, I want us to do with this. I want us to do we're going to do a set of numbers that is original, and then we're going to do a set of numbers. By the way, what does this mean right here? Greater. All right, so that means the mass is, hold on, don't answer this question out loud. I'm going to somebody by name. Okay? That somebody by name is nodule. So that right there, based on that symbol right there, does that mean my mass is going to get bigger or my mass is going to get smaller? Okay? That means the mass is going to be bigger. All right? Because it's the greater the mass. All right? So that means the mass is going to get bigger. So here we're going to say bigger mass. All right? So we're going to do it side by side. We're going to do two kinds. Okay? There's only three variables. I know this formula looks a little involved, but when you look at it, there's only three variables, K, E, M, and V. So what we're going to do is we're going to put K, E here, M here, V here. And I'm going to do the same thing over here, K, E, M here, V here. Okay? Now, what I'm going to do for this one right here is I'm going to simply take it, and this is a strategy that you should use. All right, now here's a strategy, because sometimes what will happen is you'll be given a word problem, kind of like that right there on the board, that is not obviously a math calculation problem, but you can make up a math calculation problem and help you kind of get guided to an answer. The way I do it is this. I'm simply going to use this formula, and I'm just going to use the easiest number I could use. What would be the easiest number I could use? 1. So I'm going to go here and I'm going to say my mass is going to be 1. My velocity is going to be 1. Okay? Now, when we go to your calculator now, okay, so now what I want you to do is I want you to think for 10 seconds. What is the first thing you're going to do on that calculator? Don't say it out loud, because I just want you to think. If you were doing this right now and it was a test question and you couldn't talk to anybody, what's the first thing you're going to do, all right, to answer that, to do that question? Now, I'm going to write something over here. You don't got to write it, because I just want you to see what we're kind of doing. Basically, what we're doing right now is this, okay? Like, that's the formula that we're trying to calculate. That's the math problem we're trying to do. My question to you right now is this. What's the first thing you're going to do? Be wrong, but don't say I don't know. Because like I said, right here, this is math. All right? Like if you're a sophomore or a junior or a senior, you've had it a few times in your life. You should have some idea. You can be wrong, but don't say I don't know. All right? So right here, in this particular problem, what I want to know is this. All right, Kevin, what would be the first thing you would do on your calculator?
Put in 1/2.
Put in 1/2. Okay, thank you. Now I'm going to go to Miss Little. What's going to be the first thing you're going to put into your calculator? Same thing. All right. And then Miss Holmes. I like to always go in threes. Holmes, what's going to be the first thing you're going to do?
Multiply 2.
Multiply the what? Multiply this, his? Okay. You ready? All of those three things are wrong. Okay? And that's why I want to make sure you remember the order of operation. Please stood for what? Okay, parentheses, right? But not parentheses like as in two side-by-side parentheses. They mean like whatever's happening inside of a parentheses. Okay? What does the E stand for? Exponents. Well, there's my exponent. So in this setup right here, the first thing I have to do is I have to do that number to the second power. All right? Now in this problem, it's 1, right? But don't be surprised. You're going to get a problem where it's going to be like 1.3. Okay? So that's why you have to remember. That's going to have to be the first thing you do. All right? I'll say it once. you must do exponents first. I'll say it twice. The first thing you got to do are the exponents, and I'll say it a third time. Okay? If you don't do exponents first, don't be surprised when your answer doesn't match mine. Okay? That's the first thing you got to do. If you go out of order, you're going to get a different answer. All right? Let me rephrase that. Sometimes you will get a different answer if you go out of order. Now, so when I go, so right now on your calculator, I know this is simple, but I want you to go through the habit now with numbers that are easy. So that way when you get numbers that are ridiculous, then you'll kind of know that you're still doing the right thing. So on your calculator right now, what I want you to do is I want you to go 1, right? And then however you want to do it. You can go 1 to the second power if you know how to punch that into the calculator. Or I could just go 1 times 1, right? Like it doesn't matter what number's in that parentheses right there. Like if it were 2.5, I'd go 2.5 times 2.5. Or you could do 2.5 squared. It doesn't matter, you should get the same answer. All right? So 1 to the second power is going to be what? 1. So now, what's the next thing I should do? Multiply times 1. So now that I've got that 1 squared is 1, now I'm going to go over here and I'm going to say, what's that number? Oh, that's a 1. Now I'm going to go times 1. All right? Now, obviously, this is easier because the numbers are 1. That's why I said start with an easy number, right? So 1 squared is 1 times 1 is what? 1. Now I'm going to multiply it by 1/2. You see what I'm saying? So Kevin, Michaela, right? Right? Now, notice the first thing you said was do 1/2. Notice what I'm saying? The last thing you do is do 1/2. So that's how opposite we would have been. Okay? Now, here's how you can do it. Ready? This is how I do it. So, because remember, I've told you before, like this little child's calculator is what got me through high school and college. All right? So if you know what you're doing, you don't need a big fancy calculator. But if I'm going here, I'm going 1 times 1 equals 1 times 1 equals 1. Now, here's how I do a fraction on my calculator. Okay? All I got to do now is I say times 1 for that 1 right there equals, right, 1. Then I'm going to go divided by 2 equals 0.5. Okay? So like if you said, if you don't want to have to go through the whole setting up parentheses on your calculator or whatnot, that's extra buttons. You could just go 1 times 1 equals times 1 equals times 1 equals divided by 2 equals, and then there's your answer. When you get your answer, it's 0.5. Okay? Half a joule. That's your kinetic energy right now, okay? Now, what I'm trying to remember, the whole point of this right here is I'm trying to make sure we understand what we're about to fill in that blank. Because remember, right here it says kinetic energy depends on mass. So the question they're asking, though, is, so if I increase the mass, what is that going to do to my kinetic energy? Well, right now, everybody in this room is going to say this. Either they're going to say, well, the kinetic energy is going to get bigger, or the kinetic energy is going to get smaller, right? But that's going to be a guess, because I guarantee you don't know, because you don't know until you just plug in the numbers and find out. So over here, we want to do this where the mass is bigger. Okay? So right now, let's start off with this. What should we write for mass equals? 2. So notice, all I'm going to do is, I used 1 last time, so this time I'll make it a 2. Does that talk about the velocity changing? No. So what should my velocity be here?
1.
That should stay a 1. Okay? That should stay a 1. So everybody see that right there? So do me a favor right now. Go ahead right now and go ahead and type this in your calculator and see what answer you get. Don't yell out anything. Just to see, do you do the buttons right? Did you go in the right order? Because this is one that you have to remind yourself something about. You can't do straight left to right. All right. Some of you might be there. Some of you might be on the way there. Right? V squared, 1 times 1 is what? 1 times 2 is what? 2 times 1 is what? 2 divided by 2 is what? 1. So my kinetic energy became 1. So now, when my mass got bigger, my kinetic energy became 1. What was it before? 0.5. So what happened to my kinetic energy? It got bigger. So now, what should we put in the blank? The greater symbol. Now, ready? I think this is the way I used to do it, okay? And sometimes people misread them. I call them the alligators. Some people misread them. So if you want to do it in your notes, if you want to do it like this, where you just do an up arrow, and then you do an up arrow, that sometimes seems to make it a little bit more easy for us to kind of interpret. All right? So in the mass, if you increase the mass, you increase the kinetic energy. If you increase the mass, you increase the kinetic energy. All right? Are we good with that? Okay. So now we know why the kinetic energy increases. Because if my mass increases, it increases the kinetic energy when we use the formula. Now we're going to go to velocity. So again, if you want to do the same thing, we can go right here. We can change that to an increase the velocity. What happens if I increase the velocity? Now this is something that I do want you to pay attention to, which is why it's important that we remember the order of operation. We remember that we have to go parentheses exponents before we can just start multiplying stuff and dividing stuff. So I'm going to create another column over here. Okay, I'm just going to create a third column. But to make sure that we don't get blinded by what we're trying to do here, I'm going to cover up the middle one. Okay, I'm covering up this one right there. Okay, because I want to stay with my original. Right? Here's my original. This time, what should we change? The velocity. And of course, what do you think I would change it to?
2.
To a 2, right? If I just keep the number simple, then I can't be too confusing. I'm going to keep the mass the same as a 1, okay? But I'm increasing the velocity. Like, I doubled the mass before, right? Well, now I'm just going to double the velocity. But what I want us to see here is this. I want you to see how that changes your kinetic energy. So please, for the third time now, we're going to type in these numbers in a calculator and calculate your kinetic energy. This will be the third time you've done it. So hopefully now you kind of start to get that feel for how we should do this on the calculator. By the way, if you're not getting the numbers we're getting, please get that fixed now, because you've got plenty of practice tonight. If you're not done with the calculator and you need 5 more seconds, say 5 more seconds. So I can call anybody in this room, you won't give me an answer. It could be wrong, but it's going to be an answer, right? All right. Okay, so let's go. All right. Victor, what'd you get for KE? 0.5. 0.5? All right, he got 0.5. George, is that what you got? You didn't get that? What did you get? You got 1? Okay. All right. And Deshanti, what did you get? So we got 0.5, we got 1, and what did you get? I go with my 3s. 1? All right, here we go. So if we go right here, 2, right? 2 is going to go right here, correct? So I'm going to go 2 to the second power.
4.
Okay, that's 4. All right, did you get that?
No, I did wrong.
You did it wrong. Okay, so remember, so right now go ahead and do it with us. So go 2 to the second power. All right, did you get that too when you got 2 to the second power? Did you do 2 to the second power? No. Okay, so go ahead and do that on a calculator. All right, we get 4, correct? Then we're going to multiply it by what?
1.
That's equal to what?
4.
Then we're going to multiply that by what?
4.
And that's equal to what?
4.
Then we're going to divide that by?
2.
And that's equal to what? 2. 2. Okay? But now here's what I want you to notice. When I doubled my mass, I doubled my kinetic energy. You see that? When I doubled my velocity, I quadrupled my kinetic energy. So mass and velocity, if they increase, they both increase your kinetic energy. But most importantly is this. Do they increase it at the same amount? No. That I need you to remember. Okay? I need you to remember that mass and velocity, if they increase, can increase your kinetic energy, but they don't do it the same equally. One's going to have a greater impact than the other. And in this case, velocity has a greater impact on kinetic energy than does the mass. So which makes sense, right? Because what did we call kinetic energy? Energy of what? Motion. So it makes sense that its speed is going to have more of an impact than its mass. So that's why we want to make sure we're kind of aware of that, okay? Are we good? Yes? No? Okay. That question, by the way, don't worry about this. We just wrote it down already, so don't worry about that. But that last question, right? If you pay attention literally to the past 15 seconds, what's the answer to the last question?
No.
No.
No. Okay, so make sure you put no up there because I'm pretty sure I didn't. Are we good? Are we kind of familiar with the formula now? Right? Because again, M stands for what? Mass. And mass is measured in what? Okay, kilograms, grams, right? In this case, V stands for what? Velocity. And that's measured in what unit? Meters over seconds. Okay, Zacquest, I think, wants me to throw a quiz on units because I think if I did, he's going to dominate that thing. All right, see them fractions in that exponent right there? They're the reasons why we can't do triangle. Okay, so we can't do triangle for this one. Even though it's only got 3 variables, we can't do triangle. So I'm just kind of giving you a heads up there. But, all right, we're good? Let's go to potential now. Potential energy is, well, remember, I said if kinetic energy, if we're treating energy like money, you're doing one of 2 things with money, right? What are they again?
Saving.
Spending or saving, right? And we said kinetic is what? Spending. So that means that potential is going to have to be what? Saving. Which means, am I using it? No. Could I use it? Yes. But as long as I could be using it, then it's potential. You know what I'm saying? Like, I'll say, I don't want to be tragic, but let's just say this. Let's say that Alondra wins a lottery, and she wins $5 million. Okay? So right now, she's got a lot of money. But if she dies before she ever spends any of it, well then, really, she was never really rich. Because you're only rich, I guess, if you have the money that you can spend, right? But if you never spent it, then I guess you've never really lived a rich lifestyle, I guess you could say. And that's kind of the same thing with potential energy and kinetic energy. Energy being used is kinetic, but energy that's not being used, it could, but it ain't, right? That's what we're dealing with here. So potential energy is energy when no motion is involved. Just kind of like some of you guys. Some of you guys are smart. Unfortunately, you don't do anything, right? And so you struggle, all right, in classes. Like, as the word would say, as the teacher says, right? They have potential, right? Which for me, potential, when I say that, I'm usually basically just saying that, you're not that bright. So if you ever hear me say somebody has potential, I'm basically saying, here's my nice way of going, yeah, they're not that bright. Because that's what, potential means you're not doing anything. I mean, you could be, but you're not. So imagine this. Imagine when somebody comes up to you and says, man, like, you have the potential to be so pretty. Right? You know what they're saying? You're ugly. Right? If you just to do your hair like this, so you're saying I'm ugly. No, you have that potential. So you're saying I'm ugly. Right? Because that's what I'm saying. Either you're kinetic or potential. Either you're being, either money's being spent or not being spent. Right? Either you're being used or you're not being used. Either you're smart or you're not smart. Right? Either you're pretty or you're ugly. Okay? If you've got potential, then you're not pretty. Because you have potential to be pretty, but you're not. So, that's what we're looking at here. Okay? Now, potential energy has many different facets. Okay? Big word. All right? Has many different areas of where the potential can come from. Like we just gave you 2. There's potential for intelligence and there's potential for attractiveness. Right? And then there's other potentials that you could have in life. But again, potential is based on circumstance. Right? Like, for example, if you don't, I'll just use women just because it's easier for me to deal with that. Right? If a woman doesn't brush or comb her hair in the morning and doesn't wash her face, okay? Maybe sometimes if they don't put on makeup, right? Well then, they don't look the same as if when they do. All right? I mean, that's just kind of simple. Like there have been students at prom that when they show up and they've actually done their hair and they've done makeup and they went through the process, I guess we'll call it, right? And I'm like, well, wow, that's a beautiful young lady. Never noticed that before, So, but that's kind of the same thing. Just like even some gentlemen, like when some gentlemen, like you'd be surprised at like when I see one of my basketball players, and he's actually got his pants above his waist. You know what I mean? And he's got, he's got his shirt dressed and buttoned right properly. and they walk in and they just stand taller, they look tall. I'm like, man, he almost convinced me like he's a gentleman. Except that I've seen him the entire season and realized that he's not. Right? But that's the thing. Like, wow, if you put some effort, you can actually change your entire persona. And that's what we say with potential. A good example of potential would be this. All right, let me go ahead and write down the next 2 lines. Where's my chemistry book go? I had a chemistry. Oh, there's right there. I'm going to give you an example of what we mean by potential energy. So, I'm going to use Kevin. Just because Kevin seems like he's got a personality and a sense of humor. All right, so Kevin. All right, you ready? I need you to do me a favor. Just need you to stick your hand out on the table just like that. All right? So now, ready? I have a block right here. Okay, wood block. It still is my daughter's and son's. Just they don't use them anymore. They're kind of grown now a little bit. So if I take this block and I hold it about 2 inches above his hand, are you nervous if I let go? You are nervous. Yeah. You nervous now? No. Okay? Now, if I go right here, and I hold it up here, and I let go, right? Are you more nervous than you were before?
Yeah.
Why?
Because it's higher.
It's higher up. Okay? All right, well then let me do this. Ready? This is just as low as it was before. Okay? Are you nervous if I drop this book?
Yeah.
Why?
It's bigger.
Because it's bigger. He means heavier, mass, right? What if I were to drop it now? Woo! Oh, there we go. All right, there you go. So my point here is this. There were 2 conditions for why he got nervous. One, when it was the heavy book, and then the other one was when it was the heavy book way up there, right? For example, again, when you walk somewhere and somebody says, hey, watch out for falling something, you start looking up. Why are you looking up? Because the higher it is, the more room it's had to fall, the more speed it's had to get, right? And therefore the greater potential for harm, right? That's kind of the issue. The issue here is this. Like, go ahead, put your hand again. If I'm right here, notice I love it when I do it this way, because if it hands are right, if it spine of the book, laying on your hand, right? If I do this, like, as long as it stays there, he's not going to be nervous. So why is he nervous? Because what if, right? That's the whole issue. What if it slips, right? What if, right? And that what if is the potential. Because is it doing anything right now? No, don't put your hand out, okay? It ain't. But should I, right? Oh, then now he might have a broken bone in his hand, okay? And so that's why we want to make sure we understand the difference between potential and actual. And so that's what we're dealing with here. All right, so that last line right there. After this, we're going to get to the formula for potential energy, because that one there can be confusing. But as we just said, potential energy depends on 2 things. The position, which in his case was how high up is it? Like, he wasn't worried about the block when it was right above his hand. But when it was high above his hand, he got a little bit more nervous. That makes sense. Because the higher up it is, the more time gravity has to speed up the movement. Because gravity speeds things up at what rate? 9.8. Look at Deshanti. The Saint said that correctly. 9.8 meters per second squared. For every second, it'll pick up a speed of 9 meters per second. The other condition that he was worried about was the mass. The heavier object falling. In other words, there's a reason people like me aren't at the top of a cheerleader pyramid. Okay? Because, if you got somebody like Janie at the top of a cheerleader pyramid, and the pyramid falls, nobody's really that worried about Janie falling on them. But if I'm at the top of the pyramid and that pyramid falls, then, well, let's just say it's a lot of damage that's about to happen. Okay? So, that's kind of what we're dealing with there. I'll be honest, when the cheerleaders, since Ms. Holmes is one, when y'all go to that corner of the basketball court and you start throwing that person up in the air, I get nervous. Because I was just saying, oh my gosh, he's up in the air. The potential for if they don't catch her is so, could be so damaging. Because I can tell you one thing. I've been a trainer one time for football and baseball and a couple, other sports. The worst injury I've ever seen in my entire athletic trainer career was cheerleading, because the girl at the top fell, landed on her arm, and broke it, and the thing just hung. All right, and I'm just like, oh great. All right, that's just the worst injuries. Usually the cheerleaders have the worst injuries. So, all right, let's take a look at this formula. We're looking at the PE formula. Okay, the PE formula. All right, I'm switching out of here. I'm just going to have my blank screen up here. All right, the PE formula. Now, here's why this is an important formula for us to understand. Because when you look at it, it goes like this. PE equals MGH equals F little g H. That's the formula we're looking at. Okay, that's the formula we're looking at. So, and since I'm recording this, right, you can, if you watch it again, you can't get tricked now, because I'm letting you know right now, this is not the one formula for potential energy. All right, meaning if you're solving for potential energy, you're not going to use this entire thing. All right, notice how there's an equal sign here and there's an equal sign here. What that means is potential energy can be this, or potential energy can be this. But you're going to use one or the other. So the way I always kind of teach it to you guys is this. Potential energy has two formulas. They don't write them separately on your formula sheet, so I need to show you how to separate it so that you know not to use the entire thing. Potential energy can be MGH, that right there, or potential energy can be F little g H. All right? So you're going to use either the left or the right. Okay, I'll say that a second time. When solving a problem for potential energy, you either use the left one or the right one. If you're using both, you don't know what you're doing. Okay? Because you're either going to use the left or the right. Donna? It looked like you had a question.
For the right one, ain't that one that's being affected by gravity?
They're both being affected by gravity. Okay? So that's a good point. Like, they're both being affected by gravity, so therefore the question would go, well, how do I know which one to use? And that's simple. It's simple. Let me break it down, though. So that's why we're going to do the breakdown first. Okay? So first of all, potential energy, right? This is potential energy. And because it's energy, what do we measure it in? Joule. Look at, boy, you really want that quiz, don't you? Maybe we'll do that on Friday, just to make sure you get that knockout grade. M stands for what? Mass. Mass is measured in kilograms. Okay. G stands for what? Acceleration due to gravity, right? And that's always going to be what? 9.8 meters per second squared. I'm not even going to write the name. I'm just going to put 9.8. Okay? Because some of you on that test the other day, I don't know, you just put 0. All right? You put 0, like as if you didn't know the 9.8 was on the sheet. Okay? It's on the sheet. H is a new one, but it's really not. Because what does H stand for? Height. What do we measure height in? Meters. Because, right, if you say how, what is your height, you'd say feet, right? But we don't use feet in here, we use meters. So this here is height, which is measured in meters. Okay? So now, I'm going to go to the other side. PE, again, measured in joules. F little g. What does that stand for? Weight. Yeah, it's called weight. All right? It's on the reference sheet. It was on the last test we took, too. Okay? It was on the last test we took. So F little g, that stands for weight. What do we measure weight in? Say what? Not weight. I'll give you a clue. There's a reason it's got a capital F there. Right? So what do we measure it in? Huh? Newtons. All right. Then we got H. H stands for what again? Height. What do we measure height again? Meters. So here's my question to you. What is the one unit you see on the right side that you don't see on the left side? Newtons. When I say, I meant unit. Remember, that's a variable. That's a unit. Okay? So what's the unit you see on the right side that you don't see on the left side? The newtons, right? So to answer Donovan's question, and that should be your question too. So how do I know when to use the left or the right? Well, if they give you newtons in the problem, which one are you solving with? The right. Okay? If they give you kg, which one are we going to use to solve it? The left. So that's what you got to look for. All right? Because again, both of them can get you potential energy. But again, if they gave you an n, then you use that one. If they gave you a mass, then you use this one. Because is there mass over here? No. So you shouldn't use it. Okay? Are we good right there? That's your formula? All right, let's take a look at a sample problem. Let's see here. Sample. There we go. Okay. Oh, guess I got to erase the board. All right. Remember, we have two formulas that we have learned today. All right. And so here's the problem. It's a short one, so go ahead and write this one in your notes. That way you have it to access for later. All right. It says, what is the kinetic energy of a 30 kilogram object moving with a velocity of 7 meters per second? If you don't know what the question is here, you're a serious kind of lost. So Eric, let me ask you the most obvious question, which may make me feel bad if you get it wrong. The most obvious question is this. What do they want you to solve for? Kinetic energy. All right, so Mr. Barney, what is the formula for kinetic energy? Good. So I know now, because it says kinetic energy, I need to use the kinetic energy formula. The great news is this. There's only one kinetic energy formula on the whole sheet. So if you picked the wrong one, you really didn't know what you were looking for. Donovan?
Do you still want us to do the formula solve?
Yes. Meaning, that's to your benefit. You know what I'm saying? Because again, you get partial credit. For some of you, on that last test, who gave me all those wrong units after your number answer, like you were thankful I was doing the 3-step process. Because you only lost 1 point instead of losing all 3 points. So we're going to list our variables here. So when we list them now, let me throw this one over to, let's see. Let me go to Deshanti. KE equals, what am I going to put? 32? 30. All right, I'm going to put 30 next to KE equals. Okay? All right. Nigel, what am I going to put next to M equals? 7. All right. 7. Okay. And Victor, what am I going to put next to V equals? X. All right. All right.
You're going to put the 7.
So what?
You're going to put the 7.
For the V? Oh.
Kilogram is measured, so you gotta switch. The 30 is
Oh. Okay. Okay. Why we need to know our units. Okay, so that way we know where things go. All right. Like imagine somebody came by my room and said, "Hey, I need you to give this perfume to a girl in your class." And so I just go here and I hand it to Kevin. Right? Like, yeah, I ain't a girl, right? That's exactly what I look at. When y'all put 30 at the KE, I'm like, hold on, that ain't a mass. Just like you ain't a girl, right? Okay, just make sure. No, sir. So, now, you got to do your setup. Now, you ready? For those of you who've been getting by just on the, you know what, I'm just going to take them numbers and multiply, or I'm just going to take them numbers and divide. Well, this formula is going to destroy your world. Because again, what are we doing here? We're going now KE equals 1/2 MV squared. That's what you're doing now. So if you get 210, you did it wrong. All right. If you get 4.2, you did it wrong. Alondra looks like she's done back there. So let's find out what Alondra got. What did you get? 735 joules. All right. She got KE equals 735 joules. All right. Remember, this is physical science, so we're not worried about the significant figures game. All right. But now my question is this. I'm not going to trust Alondra just because she said it. Remember, she's a lady.
You're right.
It's in her DNA to lie. All right. She's right. Donovan says she's right. Okay. Again, if you're doing this on the if right now you're going, how did she get 735? Let me walk you through it. First thing you're going to do is 7 squared. So 7 times 7, which is 49. Then you're going to go 49 times 30, right? So 49 times 30 is what, 147? 1,470?
Yeah.
Okay? Then you're going to go and take that number times 1, which would be the same number. Then you're going to go and do that number divided by 2, and that gets you 735 joules. All right. So questions on that problem right there? Like now be a great time to ask. All right. Let's do one potential energy problem. Now on this one here, ready? I'm going to stay quiet. I'm going to give you a potential energy problem and kind of make you decide which one am I supposed to use. Remember we said there's a left one and the right one, right? So I'm going to make you decide which one you think we're supposed to use. Yeah, there we go. Don't worry about that question. Just for people that are still trying to process, we are using potential energy. We're just trying to figure out, are we using the left one or the right one? So hopefully you have not written down KE equals 1/2 MV squared. All right. All I want to know right now is I just want to ask somebody what formula they use. I'm going to ask somebody, though, so don't blurt it out. Little, you avoided eye contact. I'm wondering now if there was a reason for that. Which formula did you use? Tell me now.
Is it the MGH?
MGH? Okay. She said, I'm assuming she said PE equals MGH. All right. Eric. Is that the one you used? Yes? All right then. So Michaela, you must be right. Because somebody verifies your answer. All right then. Let's go here and break it down. Nate, PE equals. What should I put next to it?
X.
X. Okay. Let's see. Nodule, M equals. What should I put? 13. Deshanti, G equals. What should I put next to it?
Wait, no. 0.
0. All right. H, George, what should I put next to it? Don't know. H is height. Height is measured in meters. 50? All right. Alonso, you going to get the right answer? No? For why? I'm sorry, let me say it in your language. ¿Por qué? Because we put a 0 for G? Oh, it's supposed to be 9.8. That's right, it says it on your sheet, right? What's amazing here is this. When we said, what is G? Deshanti even said 9.8 when we asked it earlier. Like, you gave me the number before, and then when it really counted, she forgot. All right? What do we do with all these numbers? Huh? You multiply them. And when you do, you get PE equals what? I heard nothing. 6,370 joules. Correct? Can somebody verify? Because that was Alondra, wasn't it? She's right? All right. There you go. That's how you do these problems. Now realize, there may come a problem that we do where you have to solve for like mg or h, right? So, like, I don't know how you do this. Let's say this. Like, if you got to solve for m, then you have to get m by itself, right? And so you would be PE over GH. Like, that's where some of your algebra stuff may come into play. Okay? So just realizing, remember, 4 variables can't give you a triangle. So I'm just throwing some of that stuff out there. Now, ready? The one that's going to give you the biggest headache is when you got to solve for velocity in the kinetic energy formula. Because there you're going to get a square root. All right? So just, heads up on that. All right. Does anybody have any questions? Everybody seems to do a problem? Familiar with the 2 types of energy, right? Ending.